Show using data from the graph that the process CA is isothermal. I think this might be a 3-mark question, right? Okay. Remember, an isothermal process with the combined gas law, PV over T is equal to PV over T, right? Well, if T1 equals T2, then PV over T becomes just PV equals PV, right? So look at this, right? You've got a point there where it crosses a grid line, a point there where it crosses a grid line. Here's a spot, right? Look at all these spots. Is it possible, can you show that pressure times volume equals pressure times volume? If you can show that all these PVs are the same, right? Ooh, there's another spot right there too. So find those obvious spots where it crosses grid lines, intersections, right? Where you can read both P and V and just show that the PVs are the same, right? Justify why the thermal energy loss during the compression is 1664. So you're going to use this, right? So Q is change in U plus work, right? Okay. And so let's see, it says the work done on the gas, right? Well, that means that the work is negative 1664, right? Because it's on the gas, right? Positive work is piston moves out, but this is piston moves in. So this is negative work, right? Remember that the change in U for an isothermal process is 0. Why is it 0? Because the temperature doesn't change, right? U is 3/2 nRT, and if T doesn't change, U doesn't change. I know that sounds like bad grammar, but U didn't change. Oh, that sounds good. U doesn't change. U doesn't change. All right, so this is 0, right? And so, yeah, you can just set up an equation there, make that 0. You can show that Q, the thermal energy lost, right, is that. And then calculate the change in entropy. Entropy is, this is section B2 on page 13. That 1 wanted to be something else. I think it wanted to be a 3, seriously. Okay, the delta S is delta Q, which is funny because Q is already, by the way, delta, like heat transfer, but anyway, there it is. Delta S is delta Q over T. We know what this temperature is. We calculated it earlier. It's something close to 170, right? Isn't that right? Yeah. Okay. So we know what that temperature is, and then we know the heat that flows, right? Okay. Remember that if the heat flows out, it also is negative. So just be careful with that, right? Make sure you put the right units on it and all that stuff, right? Okay. Good luck.